Imagine a flash of lightning, huge, crackling, and wild. Now picture that same force, but miniaturized and sitting safely on a lab table. Scientists have figured out how to create tiny lightning bolts indoors, letting us study this powerful phenomenon up close. Real lightning is unpredictable and dangerous, but in the lab, we can slow it down, measure it, and see exactly how it works. It's like having a wild tiger in a cage, safe, controlled, and ready for study. Instead of risking lives in storms, we now use advanced tech to make our own lightning right on a workbench. This breakthrough lets us unlock the secrets of storms without ever looking up at the sky. Today, we'll explore what lightning really is, how scientists bottle it, and why these tiny sparks could change our world. From safer buildings to better electronics, understanding lightning is a big deal. The biggest discoveries sometimes come in the smallest packages. Let's dive in and see how a flash of lightning fits on a table. Lightning is a giant spark of static electricity, like the shock you get from a doorknob, but on a massive scale. Inside thunderclouds, ice and water rub together, separating electrical charges and turning the cloud into a giant battery. The ground below becomes positively charged, creating a powerful attraction. When the charge builds up enough, electricity bursts through the air, creating a lightning bolt hotter than the sun. That heat makes the air explode outward, causing thunder. Each bolt carries millions of volts, enough to power a light bulb for months. Despite centuries of study, lightning's exact process has remained mysterious, because it happens so fast. Creating lightning in the lab lets us slow it down and finally see how it really works. Now, we can solve the riddles of the storm, piece by piece. At Penn State, scientists didn't need storm clouds. They used computer models and special materials to mimic lightning. They simulated what happens when a strong electric field hits an insulator, like glass or plastic. The models showed energy building up at weak spots, just like pressure in a balloon before it pops. In the lab, they placed thin films between electrodes and cranked up the voltage. Suddenly, a tiny, branching flash, mini lightning, shot through the material. This dielectric breakdown looked just like real lightning, only microscopic. For the first time, scientists could trigger and watch lightning form in a solid, right on their bench. These bolts were smaller than a human hair, but followed the same rules as a storm in the sky. By shrinking the storm, they created a perfect model to study lightning's secrets. It's a new window into the heart of the storm. Why bother making tiny lightning? Safety and science. Real lightning is dangerous and unpredictable, but lab lightning is safe and repeatable. Scientists can test different materials and conditions, gathering data impossible to get from real storms. This research helps us design better lightning protection for buildings, planes, and power grids. The same electrical breakdowns can happen inside electronics. Understanding them means safer, more reliable devices. By studying mini lightning, we can prevent costly damage and even fires. It's like using crash test dummies for electricity. Safer, smarter, and more effective. The knowledge from these sparks could transform how we build and protect our technology. Tiny flashes in the lab could mean massive improvements in the real world. Sometimes, small experiments lead to big solutions. Creating lightning in a lab is a leap forward in understanding nature's power. We've taken a force once feared and mysterious and made it something we can study and use. Now, scientists can experiment with lightning in ways never possible before, changing materials, shapes, and conditions. This could lead to new self-healing insulators and more resilient power systems. As our world relies more on electricity, these insights will help keep our lights on and our devices safe. The journey from Franklin's kite to a spark on a lab bench shows how far curiosity can take us. We're not conquering nature, but learning to live with it, smarter and safer. Who knows what other secrets we'll unlock next, right here on Earth? The future of science is truly electric.